Hi there. In our last section, you learned how to find the distance of a point from a plane. In this section, you are going to learn how to find the angle between a line and a plane. So let's begin. Angle between a line and a plane. Vector form. Let us consider a line with equation vector r is equal to vector a plus k vector b, and the equation of the plane p is vector r dot vector n is equal to d. And you know all these symbols and what does that mean. So I'm not going to explain that again. Now what I'm going to do, using this set of information, I am going to graph a plane and a line. So as you can see, this is my plane P right here with red color. This line with the black is the line that is on the plane. So basically this line is denoting that this line is horizontal to the plane at the surface of the plane. And this is the line L, and this green line is a normal to the plane P. Let line L and normal makes an angle of theta. So the angle between line L and this line or the plane will be 90 minus theta, because normal is perpendicular to the plane. So if this angle is 90, this angle is 90 minus theta, which is the angle between the line L and the plane P. Then the angle between the line and the normal of the plane is given as cosine theta is equal to absolute value or mod vector v dot vector n over magnitude of vector b magnitude of vector n. So basically this theta is the angle between the normal and the line, but technically what we need to find the angle between the line and the plane, which is this angle 90 minus theta. So the angle between the line and the plane is 90 minus theta. So we can write sine 90 minus theta, which is cosine theta. And let this sine 90 minus theta is phi. So I can write sine phi is equal to cosine theta. And as you know, cosine theta is equal to this value right here. So I'm going to bring that value over here. So I can write sine phi is equal to the same value over here. Only difference is that I'm using dot over here, but I use a star over here. But basically it's the same thing. I just wanted to differentiate this angle from here to here. So technically I wanted to differentiate cosine theta and sine phi. That's why I have used dot over here, but I have changed the dot. Basically it's the same thing. It's just the dot product of two vectors. So the angle between line L and plane P is sine phi is equal to absolute value or mod vector v dot vector n over magnitude of vector b magnitude of vector n. We can take sine to the other side and we can find the value of phi. So phi is equal to sine inverse this term over here, and this phi is the angle between line L and plane P.